Hello, Trig class. In this video, we are going to go over the practice test from section 8.3. And as soon as we finish the one example I was unable to finish in class today, which is on the lecture out of 8.3, this was the last example from the lecture, which I did not get to, but we can do it now. So we're supposed to verify that these two are equal to each other. And of course, they have different angles. So it'd be simpler to work with this one to simplify it to make it look like that one than to make this one look like something more complicated. So we're going to start with the complicated one, trying to make it look simple. And if you take a look at what the numerator is, it's the sum of two sine functions, which is what this left-hand side is here. You can turn in a sum of two sine functions into a product of a sine and a cosine. So let's do that. So according to that top one there, the yellow guy would be, so this would be like the sine of 2x plus the sine of 4x would be 2 times the addition of the angles, which is 2x plus 4x, divided by 2, times the cosine of the difference of the angles, which would be a 2x minus 4x divided by 2. So there's your numerator. And your denominator is the sum of two cosine functions. And according to this one, the sum of two cosine functions can be calculated as twice the cosine of the angle summed and divided by 2, and then times cosine the difference of the angles divided by 2. All right, so that's what this is. That's your numerator. Here's your denominator. All right, let's cancel the stuff that would just cancel top and bottom. These things are being multiplied, so the 2's would cancel. Also, cosine of 2x minus 4x divided by 2 is the same in top and bottom, so they both cancel out. So you'd get the top, which is the sine of 2x plus 4x divided by 2, which is sine of 3x. And the bottom is the cosine of 2x plus 4x, which is 6x divided by 2 is 3x. So that's the tangent of 3x, which is what we were trying to show. So that finishes the lecture on 8.3, and we're going to move on to the practice problem, or the practice test. As I work through the practice test, I'm going to refer to this formula sheet because you actually get to use this sheet when you come take the test, so you might as well practice with it, including during this video. Okay, let's figure out what's going on in the first one here. So this one says the cosine's negative and the sine is positive. So if you think about what quadrant that would have to be in, cosine is negative if you go left, because left is negative, right's positive. So we're somewhere in over here, but the sine is positive, and sine is the up and down one. If you're positive, you're up. So that means you got to be in quadrant 2 if you put these two sines together. The plus for the sine and negative for the cosine. So I'll just draw myself a triangle here to help me figure out the problem. Cosine is adjacent divided by hypotenuse. Side I don't know is this side, which I'll call B. So if you use Pythagorean's theorem, 1 squared plus b squared is 4 squared. So b squared is 16 minus 1, or 15. So b is the square root of 15. So now I know 3 sides of the triangle. And now I need a double angle identity, because that's a single angle that I have information on, but the question asks for the double angle. So we'll use any one of these 3 will be fine. I'll just use the first one listed, cosine squared minus sine squared. Cosine is adjacent divided by hypotenuse. Sine is opposite divided by hypotenuse. So that's just 1/16 minus 15/16 after you square those out, which is a minus 14/16 or minus 7/8. So the answer to that first one is minus 7/8. Okay, let's keep working. This one says cosine is positive. Okay, that's useful. That means you have to go right instead of left, which means it's quadrant 1 or quadrant 4. But the tangent is negative. Now, tangent is sine over cosine. So the only way that could turn out to be negative, since cosine is positive, is the sine would have to be negative. Okay, so you're to the right because the cosine is positive, and you're down because the sine is negative. Down is negative direction. Okay, and 5 is the hypotenuse. I'm sorry, 5 is the opposite side. The adjacent side is 2. And since it went down, we'll label the 5 with the negative sign. Okay. Oop, I did that, or labeled that wrong in the sense that it's opposite divided by adjacent, and the adjacent side is 5. So you go to the right 5, and the opposite side is 2, but you go down, so that's a negative 2. So this is negative 2, that's 5, and then we can get this side, which I'll call C. Use the Pythagorean's theorem. So negative 2 squared plus 5 squared is C squared. So 4 plus 25 is C squared. So 29 is C squared. And that makes the square root of 29 equal to C. So now I have all 3 sides of the triangle, and I can use my trig identity. I'll just use the same one I did here, cosine squared minus sine squared. So that would be cosine is adjacent divided by hypotenuse. So that's 5 divided by square root of 29, quantity squared, minus sine squared. And sine is opposite divided by hypotenuse. So you end up with 25 over 29 minus 4 over 29, or 21 over 29. All right, so there's that one. Okay, let's keep working. So tangent is negative and sine is positive. Sine is positive means you have to go up. So either quadrant 1 or quadrant 2. Tangent is sine over cosine. And since I know sine is positive because they told me, if you're going to get a negative out of this, it has to be the cosine that's negative. So if cosine is negative, then you have to be left, or quadrant 2. So we're in quadrant 2. Okay. So tangent is -10, and tangent is opposite divided by adjacent. We'll make 10 positive because the sign is positive, which means it's positive 10 because you're going up. But you're going left, so we'll make that negative. So opposite divided by adjacent is -10, like it's supposed to be. I don't know the hypotenuse, so I'll call that C. And we'll use the fact that 1 squared plus 10 squared is C squared. So 101 is what C squared is. So C is the square root of 101. Okay. Now you just have to use double angle identities to change it from double angle to single angle. So a double angle for sine would be 2 sine x cosine x. So I'm going to use that one. Double angle for the sine, I'll just use the same one I used in the last two, which is cosine squared minus sine squared. Double angles for tangent, I could just take the sine out of my cosine one. That'd be the fastest way to get to this answer. Tangent is sine over cosine. But if I want to practice the one off the sheet, I'll use the fact that it's 2 tangent of the angle divided by 1 minus tangent squared of the angle. 2 tangent of the angle divided by 1 minus tangent squared of the angle. That's that one. Okay, now let's just fill in the information. Okay, so this guy would be 2 times sine. Sine is opposite divided by adjacent. Cosine, it's like opposite divided by hypotenuse. And then cosine is adjacent divided by hypotenuse. So if you multiply the top out, you'll just get minus 20. And if you multiply the bottom out, you just get 101. Okay, cosine 2x is cosine squared minus sine squared. Cosine, I already did. It was a minus 1 over the square root of 101. I already did sine. When we did it, we got 10 over the square root of 101. So you get 1 minus 100 divided by 101, or minus 99 over 101. And then finally, you could just do tangent as sine over cosine, and that'd be the quickest. But if you want to practice this identity just because it's there, then you'd say 2 times the tangent, and tangent is -10 because he told me. And again, tangent is -10 because we were given that. So you're going to get minus 20 over 1 minus 100. And that's minus 20 over minus 99. Or 20 over 99. All right, so that's that example, and I will see you in the next video.